So here we go. Systems of equations. We started off talking about solving systems by graphing. What are systems? Well, a system is, simply put, it's just two or more functions. So you get two or more functions together, and that creates a system. A solution of the system is a shared point. So where they come together, where they meet up, that shared point would be a solution. All right, so this particular system right here, the first one, we have y is equal to 2x minus 1, and y is equal to negative x plus 5. So I graph both of those. I'll graph the first one. In pink. And then I use the slope to find another point. So up 2 over 1. Have a positive slope. Again, up 2 over 1. Up 2 over 1. I'm finding a bunch of points. I can also go down 2 and to the left by 1 to find more points. And you don't have to find this many. Kind of helps though with systems if you find a bunch of them, because what will happen is that you will see almost immediately the shared point where they come together. So now I'm graphing the second line of this system, and I start with the y-intercept again, so that's 0, 5. So 1, 2, 3, 4, 5. So right here, this is my y-intercept. And then using the slope, negative 1 in this case, down 1 over 1. I go down 1 and to the right. So that I create a negative slope. And again, I'm putting in a bunch of points. And we can already see that overlapped point right there that is common to both lines. I'm going to label it. One, 2, 3. So the point that they have in common is 2, 3. And I can clean that up here. All right, so I've graphed it. I found my solution. Now I want to check my solution. So to check my solution, I'm going to use a t-chart. And I'll write in my equations. So I've got 2x minus 1 is equal to y. And in place of x, I will plug in my x coordinate, 2. And in place of y, I'm going to plug in my y coordinate, 3. And then I just check it, you know. So 2 times 2, of course, is 4 minus 1. So this checks. 3 is equal to 3. I'm going to build another t-chart for the other line of this system. So negative x plus 5 is equal to y. Be careful about that sign right there. I'm plugging in 3, but my equation is the negative or the opposite of my x value. And my y value is, oh, I made a boo-boo right there. Look at that. My x value is 2. Who caught that? And my y value is 3. I'm going to toss you a piece of candy if you caught that. All right, so I have -2 plus 5, which of course is 3. And 3 right there, so this checks. So that solution, that point 2, comma 3, it is common to both lines. So we figured this out mathematically. We figured this out graphically. Now let's move on here. So the rest of the page, and by the way, you can download this page from Schoology, right? And print it at home if you missed getting your copy at school. So I've got 2 examples right here in the next bit, and we're given a point and just asked to find, oh, my highlighter's not working here. And we're asked to find out if that point is common to both lines. The t-charts are already built for this first one, so I just plug stuff in. So for the x coordinate, I'm plugging in 4. And for the y coordinate, I'm plugging in 1. Does that equal 6? Well, I've got 4 plus 2. Of course, that equals 6. So yes, 4 comma 1 is a solution for the first line here. Is it a solution to the second line? I plug them in. 4 in place of x, 1 in place of y. Does that equal 3? Yes, of course it does. So this point, 4 comma 1, is found on both of these lines. And so it will be the solution for the whole system. If I want to see that graphically, I can put this in Desmos. And let's see, I'll do something fancy here. In order to put this system in Desmos, in order to put a line in the testing version of Desmos, I need both of my lines to be in slope-intercept form. Right now they are both in standard form. How do we get to slope-intercept form? Well, we know this. We know that we have to solve for y. So I'm going to take that first line over here in the margin and solve it for y. I subtract x from both sides. Then divide both sides by 2. Divide everything by 2. When I divide this x by 2, that would be x over 2, or you can write it as 1/2 x. I think Desmos is going to like that better. You can put it in Desmos just like this. As long as you have y is equal to blah, 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 Desmos is fine with that. Slope-intercept form, the proper slope-intercept form, you're going to write it like this. For the second line, I'll write that out real quick. X minus y is equal to 3. This one's a little more straightforward. Subtract x from both sides. And then I'm going to multiply the whole thing by -1 so that my y is positive. So I just change the sign of everything. And it's fine if you put it into Desmos just like that. But proper slope-intercept form is, I just switch those around. All right, so now let's go to Desmos and try that out. All right, so on Desmos, I type in my first line. Y equals, and in parentheses, negative 1 divided by 2. Close parentheses. Be careful where that closed parentheses goes. I'm going to use my little cursor key here to get outside of that fraction. There we go. Plus 3. All right, so that is, oops, what did I forget there? Look at my line. Do you see how my line is horizontal? What did I forget right there? I forgot my x. So I put in my x. There we go. And I have a line with negative slope. Now I want to put in the second line for this system. And it is y equals x minus 3. X minus 3. And then I'm going to zoom in right here. I put my finger right there where they come together. And Desmos is telling me that the point of intersection is 4, 1. So the same thing that we had in our notes, right? All right, go back here, full screen into the notes. So it works. All right, let's check out the next example here. We've got 2 lines. I'm erasing this stuff on the side before the page gets completely full and looks cluttered. So here I've got another pair of lines, and they are also in standard form. And the point that I'm asked to check out is negative 1, 2. So I check this out by building a couple of T-charts.
Here we go. My first one, 2x plus 5y. Does that equal 8 when I plug in negative 1, 2? And the other one, 3x minus 2y equals 5. Alright, so I need to find out, is that point common for both of these lines? And I just plug it in. My x value is negative 1, and my y value is 2. 2 times negative 1, of course, is negative 2. 5 times 2 is 10. And I end up with 8 is equal to 8. That absolutely checks. Next one, I'm plugging in same point. Minus 2. 2. Does that equal 5? I end up with negative 3 minus 4.
Negative 7 does not equal 5. So that point, negative 1, 2, it is not a solution for the second line. Now, these 2 lines, they probably come together somewhere. They probably do cross each other somewhere. There is a solution somewhere, maybe, but it's not at negative 1, 2. So we'll take a look on Desmos here and find out. Okay, so before I can graph these, I will have to convert them both to slope-intercept. So the first one, 2x plus 5y equals 8. Slope-intercept form, got to solve for y. So I'm going to subtract 2x from both sides. Then divide everything by 5. If you want to spin this around so it's in proper form, that's fine. Okay. So now it is Desmos friendly. And for the second, got 3x minus 2y is equal to 5. Solve for y. Subtract 3x from both sides. Divide both sides by -2. And it's fine like it is for Desmos anyway. But we'll go ahead and put that in proper slope-intercept form. Okay, so putting both of these into Desmos. First line, y equals parentheses -2 divided by 5, close parentheses, x plus, and our y-intercept is a fraction. And you've heard me say this over and over. If you have a fraction and you're putting it into the calculator or you're putting it in Desmos, use parentheses. So there we go. That's our first line. Okay. Now the second line, y equals parentheses, your slope is 3/2, close parentheses, x minus, y-intercept is a fraction, put that in parentheses, close parentheses. Now look here, those two lines do indeed come together. I put my finger on the point, and yeah, they come together at, excuse me, 2.1579, comma, 0.7368. So yeah, the 2 points do come together. They just don't come together at -1, 2. Now, if I take a look at -1, 2, I can plot it on Desmos. Let's see, -1, 2. You can see here that it intersects that green line, that first line of our system, but it is nowhere near that purple line. Okay, how many solutions will parallel lines have? Well, we got to think about parallel lines here. Here's my XY axis. Here's a couple of parallel lines. Do they intersect? Because that's what we're talking about. Solutions are places where my two lines, my system, intersects. Parallel lines never intersect. So no solution. We will have 0 solutions for parallel lines. What else can we say about parallel lines? Parallel lines have the same slope. So any parallel lines that have the same slope, they're going to be parallel and they will have no solution. It's one of those special cases. The other special case, describe a linear system with an infinite number of solutions. And I demonstrated this in class where I picked up my parallel line here. I changed its color. So we're going to change this color to green. So now I've got a pink line and a green line. They're parallel to each other. And then I dragged my green line on top of that pink line. And what we see is that every point along either of those lines can be a solution. So these two lines can have an infinite number of solutions. Why? I would say two lines, but lines that have the same equation. They will have an infinite number of solutions. Before we get to the word problems are so much fun. Let's take a little break here. I'm going to check on my Clash of Clans. See, Miss Oak likes to play Clash of Clans. And look what we have here. I am Town Hall 15. A new Town Hall 15 right here. My resources are maxed out. I don't have a builder for another 6 hours. That's a little frustrating. Let's see. What do I have built up here? Here's my army that I built up a while ago. Let's see what I'm going to attack something. Wouldn't do me any good really to attack anything since my resources are full, but let's see here. So look here, we're going to Builderopolis. We're going to attack that again because you can see the first time I attacked it, I only got 1 star. Let's see if I can fix that. Okay, so word problem. This is on the back side of your note sheet. Bowlerama charges $2.50 per game plus $2 shoe rental. And Bowling Pins charges $2 per game plus $4 shoe rental. How many games will the cost to bowl at each location be the same? So you got a certain amount of money in your pocket and you're wondering how many games can you bowl at each location. So I'm going to need to build an equation for both of these. So for Bowlerama, I'll get my highlighter out. Bowlerama, it's $2.50 per game plus $2 shoe rental. Y is equal to $2.50 per game plus $2 shoe rental. And at the other location, at Bowling Pins, we're going to pay $2 per game plus $4 shoe rental. Y is equal to 2x plus $4 for shoe rental. All right. How many games do you get to play at each so that the cost is the same. So I'm going to use up a big chunk of the page here to build my graph. Okay. Now the first equation, I'm plotting y is equal to 2.5x plus 2. And we're not used to having slopes with a decimal in it. So I'm going to change up that decimal slope to a fraction. So if my slope is 2.5 and I want to write that as a fraction, first going to write this as a mixed number fraction, and then change that mixed number to an improper fraction. So the denominator times the whole number, that's 4 plus 1 is 5. That's going to be 5 over 2. So my slope, I can rewrite that as 5 over 2. And why do I want to do it that way? Because as a fraction, as an improper fraction or a proper fraction, this will tell me my rise over the run. Rise over run, that's important. All right, so I plot my y-intercept, that's at 0, 2. So down here, it's in green dot. And then I use my slope, up 5 over 2. 1, 2, 3, 4, 5 over 2 to find another point. And then I'm going to do that again. 1, 2, 3, 4, 5 over 2. So there's a third point. And then I'm going to go down 5 and to the left by 2. 1, 2, 3, 4, 5. 1, 2. So I got 4 points here. The reason why I'm plotting a lot of points is because I might get lucky and hit the point that both of these lines have in common. Great. So that's Bowl-O-Rama. Now I want to plot bowling pins. So bowling pins, a little bit easier to graph here. My y-intercept is at 0, 4. And then from there I use the slope of 2 to find more points. So I go up 2 over 1, up 2 over 1. Oh, that's so close. Up 2 over 1. Oh, look how close that is. Up 2 over, bingo. They both hit at that point right there. I'm also going to go down 2 to the left 1, down 2 to the left 1, down 2 to the left. Okay. And then I'm going to draw a line. Woo! By the way, I don't think we can play a negative number of games, right? So graphing those negative x values doesn't really mean anything because we're not going to play a negative number of games. Okay, so the point where they come together, I'm gonna label that point. So that's over 1, 2, 3, 4. So my x coordinate is 4. X stands for the number of games that we play. And so since this point is common to both, then we're going to play 4 games at both locations. And how much will it cost us? Well, I've got to go up the y-axis here. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So if I play 4 games at either location, it's going to cost me $12. So if I got $12 in my pocket, guess what? You can safely bowl at either location and in 4 games. So that's a pretty good deal. Okay, so that is our lesson on graphing systems. The next in this series will be systems of equations substitution. Adios.